Today we are going to look at how do we try to put together the picture of the cladogram, how things are related, how things could be connected. As you saw from working with the cladograms on Wednesday, there's many different ways of showing relationships. The first thing that we're going to critique is the fossil record. The fossil record is looking at the remains of organisms. These are not bone remains. Fossils are different. Do you know how a fossil forms?
Extinction. No, something that's done.
Okay, so it requires that the skeletal remains, or whatever is left of the organism, is buried very quickly so there's very little decomposition. So that's the first condition. What else does it require? So, yes, pressure, but most importantly, water with lots of minerals in it. We call it hard water. And those minerals will actually take the place of the bony material. And when those minerals crystallize and solidify, as the bone is broken down, the minerals take its place and you're left with a fossilized structure. Not all organisms leave fossils. For example, if you have something die out on the farm, you usually have a spot in the back of a field where you kind of drag the stuff to, right? You have bone remains. But not all of those would be fossilized. If you were to come back to that bone pit in 200 years, you would not necessarily have all of those remains present. Because over time, bone, like any other cell, is going to be broken down in the environment. Fossils remain, because essentially, a fossil is a rock. You might have heard of petrified wood. So this looks like a rock. It's actually a piece of wood. The minerals have seeped into the wood, and as the wood decayed, the minerals took its place. You see petrified wood in places that have experienced volcanic eruptions, and there's lots of minerals that have been thrown up into the air, and they become a part of the environment. The ash gets absolutely everywhere, and eventually the minerals seep into the actual tree or plant, and when the water evaporates, you're left with these solid forms. In Northern California, you come across a very large petrified forest. Yeah, it's really cool to go drive through and visit. What they do is they take a look at fossil structures and try to look for similarities in the parts of whatever they find. Is it the fact that it has a similar crest on the back of the head, or similar dentition, or teeth-like structures? This is a skull. And every week, this person does what's called a skull Sunday. They put up a skull, and you have to see if you can identify what the skull is based on the features of the skull.
Look at those teeth. I think that's a beaver.
I'll give you a hint. It is a mammal.
I'm worried it.
Do you think that this mammal is a carnivore or a herbivore? How can you tell?
The teeth.
If you look at the incisor right here, and if you look at the mountaintop shaped teeth, yes, this cuspid is very characteristic of a carnivore. This is looking at the roof
That's a warthog.
of the mouth. The reason why we're interested in looking at the roof of the mouth and the bottom of the jaw is so that we can do teeth counts. So a mammologist would start to count how many front teeth there are, how many incisors there are, and they would count how many back teeth there are, and that leads to clues.
What is that?
Let's look at the bottom part of the jaw. Again, we could do teeth counts that would help us to identify what this organism could be. Are there any other characteristics that help you? The V shape. That is something that is very characteristic of the Canis genus. This is a side view of the bottom jaw. How come there are holes in the jaw? So you have a foramen right here. A foramen is just a fancy word for a hole. And a foramen here. Nope. That's where the nerve passes through. So a nerve needs to be able to pass through the jaw to control muscles alongside of the jaw, which help in order to move the jaw. Give you a hint, it's a domesticated mammal. Domesticated means that we have intentionally trained this animal. It usually lives in our homes as a pet. It's a dog. This is a dog skull. We won't know that based on skull features. There are some animals, like a pug, for example. You would be able to clearly identify a pug from its skull. But other mammals can be very tough, especially since we do not have any measurement rulers beside this. If we were to find this skull in the field and post it to a forum like Twitter, we would usually use a field ruler. It's usually white and black or yellow and black, and it's usually an L-shaped ruler, and you would put that ruler beside the skull so that you would be able to communicate proportion. Here, the skull looks like it could be for a small or medium-sized dog, but really it depends on how far away the person is taking the picture. There is no scale representation. So while this is a skeleton and not a fossil, if this was a skeleton or this was a fossil, we would be able to use similar clues to try to determine what this came from. Based on clues in the dentition, the jaw shape, we could look at the structure of the eyes, the position of the eyes. We could then start to make comparisons to what we do know. That is a benefit, but it's also a limitation of using fossil records. We're always comparing it to what we do know. That can lead us astray sometimes, because if we go into fossil identification with a bias and say, oh, I think this belongs to something related to a pig, well, that can narrow our vision, and we just look for evidence of pig relationships. We have to keep a broad mindset when we're doing fossil identification so we don't get into this It's called confirmatory bias. Have you heard of that before? Okay, confirmatory bias is when you look for evidence to support what you think it is, at the expense of ignoring other types of evidence. Sometimes we see this in the way that people structure their logical arguments. They only look for evidence that supports what they say, and they intentionally don't look for any other evidence. Similar appearance suggests that there could be a relationship between organisms. The big howevers. Not all remains are fossilized. What this means is that we only might find a knee bone, or a partial jaw, or a tooth fossil. We might not find a whole entire organism, which means they could be doing a lot of guesswork. Fossils can be compressed, and that can distort their features sometimes. Sometimes people will deliberately piece together fossils.
It's pretty close to that there.
It could be. We don't have enough picture of a snout. So there was a fossil that people thought was the tie between birds and dinosaurs. It was published on the front cover of the National Geographic a couple of years ago, well, many years ago. And National Geographic is generally thought to be an organization that has very high standards and has a high authority in its field. When it was discovered that this fossil was not what it was thought to be, it was quite embarrassing for them. We've had people who have taken different pieces of fossils and put them together to try to fake the discovery of a new animal. Unfortunately, it is something that we do have to be very careful about reading about.